If you're watching this video, you may be already familiar with data center networking technologies. But did you know that most of the transceivers deployed in the data centers are multimode? And have you heard of the IEEE 802.3 dB working group, which is defining the requirements for next generation 400G and 800G multimode transceivers? Hi, I'm Adrian. I'm a data center networking expert with Keysight Technologies. And today I would like to showcase some of Keysight's latest innovation to design, test, and validate multimode interface based on VCSELs modulated at 106 gigabit per second based on 53 gigabaud PAM4 modulation. The industry is working full steam on this low-cost and power-efficient technology that will accelerate the deployment of 400G and 800G in the data center. However, vertical cavity surface emitting lasers, short VCSELs, offer less bandwidth than their single-mode counterparts, and multi-mode links suffer from specific propagation effects such as mode coupling or modal dispersion. Therefore, extended equalization is required at the transmitter and receiver side, and new robust design for clock and data recovery are mandatory. Behind me is the setup I would like to discuss with you today. Here you can see a A400G EQDD. This is a 4-port tester for 400G transceivers and DAC cables. Here you can see a 400G based SR8 transceiver operated in optical loopback. The A400G EQDD can measure bit error ratio, generate and detect fake encoded traffic, measure frame loss ratio, and even send Ethernet packet. You can count, capture, and analyze error bursts. This is particularly relevant for multi-mode interfaces where mode hopping in the VCSEL or complex equalizer adaptation schemes can generate error bursts. Because multi-mode optical modules operating at 106 gigabit per second per lane are not commercially available yet, we use a M8194A arbitrary waveform generator combined with a 81491A optical reference transmitter to generate a 53 gigabaud PAM4 multimode signal that we want to analyze on an optical sampling oscilloscope. But for this, we first need to recover the clock of this signal. Keysight recently introduced the N1077B. This is the industry's first 64 gigabaud NRZ and PAM4 multimode optical clock recovery. Combined with the N1092 series of sampling oscilloscope, it is tailored to be used in R&D or validation labs or in a manufacturing environment. The incoming signal is split in two paths, one used for clock recovery and the other being redirected to the scope. The recovered clock is then passed to the sampling scope to capture and analyze the signal. The N1010A FlexDCA software is used to control the clock recovery and sampling scope units. In the clock recovery control plane, you can select the symbol rate and the target loop bandwidth. You can even carry out some advanced measurement such as jitter spectrum analysis. On the sampling scope side, you can select the wavelengths calibration and also select the receiver bandwidth. Here in this case we select a bandwidth of 26.6 GHz, which corresponds to the Nyquist frequency of the incoming signal. This is a requirement to compute the TDCQ metric. But this is not the only one. A TDCQ equalizer must be used to equalize the received signal. For single-mode interfaces and 26 gigabaud PAM4 multi-mode interfaces, a 5-tap FIR filter with optimized taps coefficient is sufficient. But for this next generation of multi-mode interface, 7 or even 9 taps may be required. The FlexDCA software can compute metrics such as average power, extinction ratio, linearity, and TDCQ. But as you can see, our incoming signal isn't totally closed, but the bandwidth of VCSEL is really expected not to exceed 30 GHz, so you may have to deal with even more distorted signals. To verify the performance of the N1077B clock recovery, we load an unequalized waveform on the EduWG. So here is a resulting signal. On the left you can see that the incoming signal is totally closed. You cannot distinguish between the levels. The resulting TDECQ is above 4.5 dB, but even in this case, the N1077B clock recovery can recover the clock of this signal. I hope you enjoyed this short video. If you need more information, please visit www.keysight.com/find/800G or reach out to your Keysight representative. Thank you for watching and goodbye.